What if I told you that any trip you take to the future is a one-way ticket? I know, it sounds wild, but today we're diving into one of the most mind-bending ideas in all of science. And this isn't fiction, folks. This is a fundamental truth of our universe.
I mean, just pause and think about that for a second. Imagine hopping on a ship, taking a quick trip around the block, cosmically speaking, and coming back to find that centuries, even millennia, have passed on Earth. It sounds like something straight out of a movie, right? Well, here's the kicker. It's not. This is the actual reality of the cosmos, and it was all described with incredible accuracy by Albert Einstein more than 100 years ago. So let's get into how this is even possible, and it all starts with the very thing keeping your feet on the ground. Our journey begins by pretty much throwing out everything you probably learned about gravity in high school. It's way, way weirder than you think. For centuries, right, we all went with Isaac Newton's view. Gravity was this invisible force, like a rope, mysteriously pulling objects toward each other. But then Einstein came along and completely flipped the script. He said gravity isn't a force at all. It's just a side effect of the shape of the universe itself. Now, to get your head around that, we have to talk about this crucial concept, spacetime. See, Einstein realized that space and time aren't two different things. They're actually woven together into a single, flexible, four-dimensional fabric. Everything, you, me, the planets, the stars, exists within this fabric. Okay, so here's a great way to picture it. Imagine space-time is a big, stretched-out rubber sheet. Now, if you drop a heavy bowling ball, let's say that's our sun, right in the middle, what happens? The sheet bends, it curves, it creates a dip. Now, if you roll a little marble that's a planet nearby, it doesn't get pulled by the bowling ball. It just follows the curve that the bowling ball made in the sheet. And that's exactly what's happening with planets. A planet orbiting the sun thinks it's traveling in a perfectly straight line, but it's actually moving through a part of spacetime that's been warped by the sun's huge mass. That's gravity. It's not a pull, it's just geometry. Wild, right? So the universe can literally bend. But it's not the Wild West. It has rules. And maybe the biggest, most unbreakable rule of all is the cosmic speed limit. Yup, 300,000 kilometers per second. That is the ultimate speed limit of the cosmos. The speed of light, which scientists just call c. And this isn't a suggestion, you guys. It is an absolute ironclad law of physics.
So why can't we break it? Well, the physics here is just fascinating. As anything with mass starts to speed up, its own mass actually begins to increase. The closer and closer you get to the speed of light, the heavier and heavier you get, until, at the exact speed of light, your mass would become infinite. And, well, moving an infinite mass would take an infinite amount of energy. So the universe itself literally puts the brakes on.
But this is where things get really, really weird. The speed of light is constant for every single person who measures it. It doesn't matter if you're standing still or flying in a rocket at 99% of light speed. If you turn on a flashlight, that light will always move away from you at speed c. So if the speed of light can't change, something else has to. And that something else is time itself. This is the part that just completely shatters our everyday experience of reality. This mind-bending effect is called time dilation. You see, to keep the speed of light the same for everyone, the universe makes a trade-off. Think of it like you have a total budget for how fast you can travel through space-time. The more of that budget you spend on moving through space, the less you have left over for moving through time. So for you, in your super-fast spaceship, time itself literally slows down. So let's make this real with a classic example, the twin paradox. Imagine one twin stays home on Earth while her sister blasts off in a spaceship at nearly the speed of light. For the twin on the ship, maybe only 5 years go by, but when she finally gets back to Earth, she finds that 35 years have passed for everyone else. Her Earth-bound sister is now 30 years older than her. The space twin has, for all intents and purposes, traveled into the future. And it's not just about speed either. Remember how gravity is just space-time curving? Well, that curvature also messes with the flow of time. The deeper you are in a gravity well, like the closer you are to a massive planet or a star,
the slower time actually ticks for you compared to someone much farther away.
And look, this isn't just some abstract theoretical nonsense. You rely on this science every single day. The satellites that run our GPS network are way up high, where Earth's gravity is weaker. That means their internal clocks actually run a tiny bit faster than our clocks down here on the ground. If your phone didn't constantly correct for this time dilation, your GPS would be off by miles within a single day. It's real, and it's essential. Okay, so let's just take a breath and try to put all these crazy threads together. What does this new picture of the cosmos really mean?
It means that our common sense view of the world is, well, it's just an illusion, really. Space isn't some static, empty box. It's a dynamic, bendy, stretchable fabric. And time isn't this universal clock in the sky taking the same for everyone. It's more like a river that can speed up, slow down, and flow at different rates all across the universe. Einstein gave us a completely new rule book for reality, a universe where a trip to the stars is also, by definition, a trip through time. And that just leaves us with this one final amazing question. If something as basic as time is this weird and flexible, what other profound secrets about how reality works are just sitting out there, waiting for us to discover them?